Alright, so this is the third video on similar triangles, and I just wanted to do kind of a short one. I know there's two others, but I wanted to do one more that involves word problems, just so you get a sense of what they'll be like on the assessment that you take, and what they'll be like on AIMS as well. So here is one example. And usually the best thing, especially when you're dealing with similar triangles like this, and you have word problems, you want to draw pictures. So let's read the question and see how we can draw a picture. So it says if a 5-meter flagpole casts a 10-meter shadow. Okay, it says how tall is a nearby house which is casting a 20-meter shadow. And so the first thing I like to do is just draw pictures, right? So I'll do my best on here to draw a picture. So let's say, let's maybe get a line here for the ground. So this will be our ground. Okay, and then we'll draw a flagpole. So this will be our flagpole here, right? Okay, and so the flagpole, let's make it have a flag. See if I can draw a flag on it. All right, that's our flagpole. And what it's saying is it's casting the flagpole here is 5 meters. So let's write 5. And then it's casting a shadow, and we'll make the shadow yellow here. That is twice as long, and so it's about right there. And so that's going to be a shadow that is 10 meters long. So here we go. This is 10 meters. Okay. And then there's also a shadow from a house. It says that is 20 meters long. So we have a house here, and its shadow is 20 meters long. So let's say it stops there. And so let's write 20 here. 20. And I'm going to draw a house. So I'm assuming the house is taller than the flagpole. Okay, so we'll draw a house here, and we'll draw a house here. Oops. And there's our house. And we want to know how tall this house is. And so when we don't know something in math, when we're trying to find it out, we usually give it the value of x. Okay? And so, how this deals with similar triangles is if you imagine drawing a line, and maybe I'll do this as a dashed line, see if I can do that. A dashed line, and we'll make it a different color. How about this? If you imagine drawing a line from the top of that flagpole to the end of that shadow, that right there forms a triangle. So there's one triangle, right? And then you got another one here from the top of that house down to the end of that shadow. You have another one. And the reason these are similar triangles, right, is we're assuming they both have a right angle here. So that's one angle that they have congruent to each other. And then if we imagine the sun is at the same spot, then the shadow is going to come down at the same angle. Okay, these are both going to have the same angle. So what that's going to tell us is that these two angles are the same. So we can assume these are similar triangles. But anyways, that's just probably a little more detail than you need. But anyways, that's why these questions are in with the other similar triangles. And so what we're going to do is set up a proportion. Okay, and so what I always like to do is make sure my x gets on top. So that's going to be put my x on top here, right? And is equal to, right? And so if I say this is x, that goes on top of my fraction in the numerator, I guess. Then this also needs to go on top. So this 5, those go together. And so the x and the 20 are going together. And the 20 to the bottom, so the only number left is the 10, and so that's going to go on the bottom as well. And so now we just need to get x by itself. And so to do that, what I'm going to do is multiply each side by 20. Okay, 20 times this side are going to cross those out. And I'm going to multiply the right side by 20. Okay, and so on the left side, all I'm left with is just an x. On the right side, I have 20 times 5, which is 100, correct? So this is 100 over 10, which we can reduce, right? We can cross those zeros out, and we're left with 10 over 1, or x equals 10. Okay, and so what that tells me is The height of this house is 10 meters. Okay? So that's one type of question you're going to see in your assessment. Another one that might be a little more challenging is this one right here. It's got a little bit more words to it, but it says two cars start out at the same point on a straight road and travel 3 miles in opposite directions. So let's try and see if we can draw that. So here's, let's say they go out, this one goes up 3 miles this way, and then this car goes up 3 miles this way. So they're going in opposite directions. This car is going, maybe I can give these different colors here. This car is going, the red car is going to the right, and the black car is going to the left. And they both went 3 miles. So let's write that down. So as we're reading the question, we are writing down what information we get. So this is 3, and this is also 3. So then it says both cars then turn left, okay, on a perpendicular road and travel 4 miles. So this car is going this way, and then it turns left. So if you can imagine being in that car and it turns left, that car then is going to be going this way. And then perpendicular, remember, means a right angle. So it's got to go at a right angle. And it goes a little bit further than 3, right? This is 4, so it should be a little bit longer than the first line. So maybe right about there. If you can imagine this car, it's going to the right, and if it turns left, it should be going upward 4, right? And so we're going to kind of cut into our word problem, but that's okay. We'll be all right. And so those are both 4 miles. So let's write that as we read the question. So it's good to just keep drawing pictures and adding the information as they tell you. Okay, and so these are right angles again, right? So we should probably mark that. Remember, perpendicular means it can have a right angle. So those are right angles there, because those are perpendicular lines. What is the distance between the two cars? Okay, and so what we need to figure out is basically how far, and let me see if I do this in a different color. Let's say blue. How far is it from this car, because that's where the car just ended up, to this car way up there. Okay, and so what you could see there is this is actually similar triangles, or actually congruent triangles. And you could actually, if you really wanted to, you wouldn't have to use similar triangles here. You could use what we call Pythagorean theorem, and that might even be a better way to do this question. So what we're trying to do is figure out this long blue line, and so what we're going to do is we need to figure out, how far is it on this line right here, and then we need to also figure out how far is it on this line, and then if we can add those two together, that'll give us the total distance between the two cars. And so these are the exact same triangle. This has 3 and 4, 3 and 4. Okay, and so that means if I can figure out the green distance or I can figure out the yellow distance, they're going to be the same. So then I can just either double it or add it together, the same thing. So let's see if we can figure this out. And so since this is a right triangle, the thing you should always think about when you hear right triangle is the first thing that always comes to my head is the Pythagorean theorem. And so what that tells us, remember, let me get off the highlighter here, is that it's the leg squared, or a squared, plus the other leg squared, or b squared, equals the hypotenuse squared, or c squared. And so that can actually help me get this answer. And so your legs are always the sides of the triangle that are touching the right angle, so that would be this side and this side. And then your hypotenuse is always across from the right angle. So my hypotenuse is this yellow line, or in this triangle it's the green line. And so let's just call that x. So my hypotenuse, which is the one that goes on the right side by itself, is x squared. Okay, and then a and b are the other two sides, so it's 3 and 4. So it's going to be 3 squared plus 4 squared. And you might know this, that these are called special or 3, 4, 5 triangles. If you know that, then you're going to know x is 5. But let's go ahead and work through it. So 3 squared is 9. 4 squared is 16, and that's x squared. 9 plus 16 is 25, And so we get x squared equals 25. Okay, and so remember this x squared, you don't divide by 2 over here. What we're going to do is we're going to take the square root of 25. So the square root of both sides, because that's going to undo the square. So the square root and the square cancel out, and we get x equals the square root of 25. So you want to think to yourself, what two numbers multiply together get me 25? And the answer is 5. And so what that tells me is that x is 5, right? So this length right here is 5. The yellow side is 5. And as we said before, the green and yellow are the same, so this green is also 5. And so how far is it from this card to this card? Well, it's this 5 plus this 5, so it would be a total of 10 miles. And that would be your answer. Okay, and so on your assessment today, you're going to see a couple of these questions along with regular similar triangle questions. So hopefully this helps out a little bit.